This is lesson 6 of chapter 7, and the title of this lesson is Cross Sections. And we go back to the essential question, how does geometry help us describe real world objects? Okay, so all throughout this lesson, we've been talking about angles, triangles, classifying them, and seeing how they are related to everything that we see all around us. So in this lesson, we're going to talk about more of that. But this time we're going to talk about what we call cross sections. Okay? The vocabulary that we'll be discussing in this lesson are the following. There's a bunch of them. So take note of these. Prism, basis, pyramid, plane, coplanar, parallel, polyhedron, edge, face, vertex, which you already know, diagonal, skew lines, cylinder, cone, and finally cross section. Okay? And at the beginning of this lesson, what we learned here, scan the lesson, write the definitions of the polyhedron and the face. And definition of a polyhedron is a solid with the flat surfaces that are polygons. So it's a solid with flat surfaces, which are polygons. We'll understand what polygons are in a minute. A flat surface, a face is what we call a flat surface of a three-dimensional figure. So we talked about three-dimensional figures in past lessons, and the flat surface of that is called a face, okay? And the newest term that we are going to be talking about will be a solid with flat surfaces. There are polygons, which are also called polyhedrons, okay? So in this particular lesson, we start up with the vocabulary. And in our vocabulary, we will define what a prism is, what a base is, and what a pyramid is. Let's take a look at that right now. So a prism is a three-dimensional figure. Again, it's a three-dimensional figure with at least two parallel congruent faces called bases. Okay? That are polygons. A pyramid is a three-dimensional figure with one base that is a polygon. Its other faces are triangles. Okay, now let's take a look at this definition for a minute here. So we know that a pyramid is a three-dimensional figure, meaning it is 3 dimensions, length, width, and height. Okay, with at least two parallel, okay, congruent faces. Parallel means lines that do not meet. So when you talk about parallel lines, they are lines that never meet. Okay? But in this case, they are faces. So they are flat. Okay? So these are two parallel faces that never meet. They're congruent, meaning that they have the same measure. So if you have two of these things and they're parallel to each other, which means they never meet, okay, and they are congruent to each other, okay, uh, you might have what we call a prism. Okay, again, a polygon, okay, comes with the word poly means many, okay, and gon means sides. So this is simply a figure with many sides, and a triangle is one of them. It's a two-dimensional figure, not three, okay, which has more than two sides. So it's three sides or more. That's what we call a polygon, okay? So going back here, a prism is a three-dimensional figure with at least two parallel and congruent faces called bases. So these are called your bases. There are polygons. In this case, this is a quadrilateral. That's a quadrilateral. That's what a prism is. A pyramid, on the other hand, is a three-dimensional figure with only one base that is a polygon. Its other faces are triangles. So in this case, if we connect these, the legs here, this is what we call a prism, and this is actually a rectangular prism. Okay? So a pyramid will only have one base and the other faces are triangles. Okay? So knowing those definitions, let's go through this. Write a pyramid, a prism or pyramid, and the line on each figure. Obviously, this has two parallel bases right here and right there, and this is called a prism. Okay? This has only one base right there, and its other faces are all triangles. So this is a pyramid. Okay? Again, one base. Okay? Other faces are triangles. So this is again a pyramid. Now this becomes tricky right here. If you look at this one, it has two bases right here, this base and right base, and they are polygons, and these polygons are triangles. And look at the other faces. The other faces are all rectangles. Okay? And this is what we call a prism because it has two bases. Okay? So if you have two congruent bases, this base is congruent to that base and they're parallel to each other, they're called prisms. Okay, let's take a look at the real world link and see how we can see this outside. The Rock and Roll Hall of Fame is shown at the right. This is the shape of a building. Is the shape of a building a prism or a pyramid? So if you notice, it is the faces are all triangles right here, and the base is a rectangle. So this is a pyramid. Okay, it is a pyramid because its faces are triangles, and it has only one base. Okay? All right. Let's take a look at the lesson proper and let's see how this lesson goes. Okay? So we start off with definitions. Okay? We talk about different terms here and pay attention to the terms that are going to be discussed in this particular lesson. So first we look at a plane. A plane is a flat surface that goes on forever in all directions. Okay? So think of this as a sheet of paper. If that sheet of paper goes in all directions forever and it does not stop along the borders, then that's an example of a plane. The figure at the right, which is this one right here, okay, shows the rectangle ABCD. So ABCD, this is our rectangle. Line segments AB and DC are coplanar. AB and DC are coplanar. Why is that? Because they lie in the same plane. And that plane is plane J. Okay? They are also parallel to each other, this one and that one, because they will never intersect no matter how far they are extended. So what it's saying is this: if I extend this line here forever and DC, I extend it forever this way, these two lines will never intersect. Okay? And that's why they are considered to be parallel to each other. Okay? So just as the two lines in a plane can intersect or be parallel, there are different ways that planes may be related in space. Okay? Now, a lot of uh, words that are hard to understand here. Again, just as two lines in a plane can intersect, meaning two planes just like plane J can intersect, okay, or be parallel to each other, there are still a lot of ways that these planes may be related in space. Let's take a look at one of them. Okay? So when you talk about they intersect in a line, so two planes can also intersect in a line. So you have this plane right here, and the green plane, the blue plane and the green plane, okay, they intersect in a line, which is line L. Okay? So if you have two cardboard pieces, for example, and you make them intersect, they will intersect at what we call a line. They can also intersect at a point. So how does that work? So if you look at three planes here, the blue plane, the green plane, and the yellow plane, if you notice when they are all put together and they you can see that they only intersect at point A. Okay, so again, it takes a little bit of imagination here. The green plane and the blue plane and the yellow plane, when they are put together, they all only intersect at point A. Okay, and finally, if you have two planes that are parallel each other, okay, that means they will never intersect. That goes with this blue plane and the green plane. These are called parallel planes. Okay, just like what we have in a prism, you have two bases that are parallel each other, which will never intersect. They're called parallel planes. Okay, now those are done. Okay, if you need to understand or if you need to review the definitions, just rewind this video. So when we talk about intersecting planes, can come from three-dimensional figures. A polyhedron now is a three-dimensional figure. We'll define that. Three-dimensional figure with flat surfaces that are polygons. Okay, that's a polyhedron. Remember, a polygon is two-dimensional. A polygon is two-dimensional. A polyhedron is three-dimensional. Okay? Prisms and pyramids are both polyhedrons. Some terms associated with these three-dimensional figures are edge, face, vertex, and diagonal. So once you start talking about a polyhedron, which is a three-dimensional figure, okay, you can find an edge, a face, a vertex, and a diagonal. Let's take a look at this prism at the bottom. You have that rectangular prism at the bottom, and let's identify what an edge is. So an edge, okay, is where two planes intersect in a line. So these are the edges. Okay, let's say you have this plane, and these are the edges because these are the planes that intersect at that line. Very similar to what we talked about here. So these are the edges of our prism. Okay? Next thing we're going to talk about is what we call a face. A face is a flat surface. This is a face of our polyhedron or our prism. So the flat surface represents our face. Okay. The next thing we're going to talk about is the vertex, and we know the vertex for a fact because where three or more planes intersect at a point. So in this case, these are our vertices, where three or more planes intersect. So in this particular prism, you have 8 vertices. Okay? And you have, let's count the number of edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 edges. And you have 6 faces. Okay? And finally, the last one we're going to discuss is what we call a diagonal. A diagonal is the line segment, okay, whose endpoints are vertices that are neither adjacent nor on the same plane. Now take a look at this one right here, and this is a little bit confusing. It takes a little bit of imagination. And in this particular prism, HB is our diagonal, okay, because they are neither adjacent nor on the same face. So H, it belongs to this point H belongs to this face, point B belongs to this face, and these faces are neither adjacent or next to each other, so that's our diagonal. Another diagonal, if you want to really look at it, is point C, okay, to point D. CE, I'm sorry, is another diagonal that we can use. Okay, now the diagonal can be GA, okay, and so on and so forth. Okay, so those are some definitions. We also notice that in figure above, segment GC, okay, and DA do not intersect. Look at this, GC and DA do not intersect, okay? Why? Because they are in different planes. So these segments are not parallel because they do not lie in the same plane. So they're not parallel because they're not on the same plane. Lines that do not intersect are not coplanar, meaning coplanar means same plane. Okay? Coplanar simply means they lie on the same plane. If they are lines do not intersect and are not coplanar, they're called what we call skew lines. So GC and DA are skew lines. Okay? Another example of skew lines, HE and GC are also skew lines. Okay? I can also look at FB, okay, and HE are also skew lines. They're not parallel, and they do not and they do not intersect. Okay. Okay. Let's talk about more terms, and let's talk about what a cylinder is. There are also solids that are not polyhedrons. Remember, a polyhedron will have a flat surface. A cylinder is one of them. So a cylinder is a three-dimensional figure with two parallel congruent circular bases connected by a curved surface. So when you talk about a cylinder, it has two congruent circular bases and it's actually connected, okay, by a curved surface. This is the curved surface of our cylinder, I'm sorry. Another solid that's not a polyhedron is what we call a cone. It has one circular base connected by a curved side to a single vertex. Now, a good thing to look at that, okay, my cylinder is nice, but this is a good example of a cylinder right here. These are your two circular bases, and this is the curved surface, okay? Think of a Pringles container, for example, that is a cylinder, because if you cut the curved surface, okay, if you cut the side of your Pringles can, you will notice that it is a curved surface. A cone, for example, you know what it looks like. This is a cone because it has only one base, okay? It has only one circular base connected by a curved side to a single vertex. So this is your single vertex, and a party hat is a good example of a cone. Okay? Lot of definitions. Rewind the video if you need to understand these definitions more. Okay, let's take a look at some examples here, and let's see how we can apply all that we've learned. So we want to identify the figure, name the bases, faces, edges, and vertices, then identify a pair of skew lines. Okay, so in this case, we know that you have a triangular face and you have only one base. So this looks like a pyramid. And if you notice, the base has five sides. Okay, a polygon with five sides is also called a pentagon. Okay, so the base is shaped like a pentagon, five sides. Okay, So this is what we call a pentagonal pyramid. So the figure has one base that is a pentagon, so it is a pentagonal pyramid. Okay, if we are to name the base, we can name it as RSTUV. RSTUV. So we simply identify all the points on that particular pentagon. Okay, the following faces are these triangular faces, and there are 5 of them. And if you look at our faces, you have R, S, TUV. RSTUV is a face because that's also a base. When you look at the base, it is also considered to be a face. QVR, QVR, that's one triangle. QRS, QRS, QST, right there. QTV, QTU, I'm sorry, and QUV. So those are the 5 triangular faces and one pentagonal base, which is also considered to be a face. Okay, the vertices are where the points meet. So these are vertices of our pentagonal pyramid, and the vertices are QR, edges first. The vertices are QRSTUV. Edges are where the faces meet, and it's QR, QS, QR, QS, QU, QB, VR, RS, ST, TU, and UV. So basically, all these lines where the faces meet. So if you want to find skew lines where you have 2 faces that are not parallel to each other and they will never intersect, these are QV, which is this one right here, and TS. So they're not coplanar and they will never intersect. Okay? All right, let's take a look at the second example. In the second example, you have a figure again with 2 bases. So if you have 2 bases that are parallel and congruent to each other, okay, it is called a prism. And since the shape of our base is a rectangle, this is called a rectangular prism. So you have 2 rectangular bases that are parallel and congruent to each other, so this is called a rectangular prism. Okay? So there are 2 bases here, so that means we name our base as ABC, D, that one right there, and EF, GH, right there. Okay? We can also name 2 bases as ABFE. ABFE, we can make this a base, and we can also make this a base, DCGH. Okay? And ADHE, ADHE, this one right here, and this can also be your 2 bases right here, BCGF. So any of those pairs are considered to be bases. So those pairs are considered to be bases of our prism. So the faces remain the same. The faces are the flat surfaces, these ones right here, and these are the names of all the faces. There are 6 of them because in a rectangular prism there are 6 faces, and there are 8 edges. 12. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. All these lines are your edges. And there are 8 vertices to this. Okay, A, B, C, D, E, F, G, H. These points are all your vertices. And your skew lines are AE, can be AE. And and FG right here because they are non-coplanar and they will never intersect. Okay? All right, that's a mouthful for these two examples. Do the guided problems and let's see if you understand example 1 and 2. Examples 1 and 2. Okay, let's talk about what cross sections are. So the intersection of a solid, okay, remember solid is a three-dimensional figure, and a plane is called as a cross section of the solid. So how does this work? Let's find out. Example 3, we'll find out. So describe the shape resulting from a vertical, angled, and horizontal cross section of a square pyramid. So again, in this particular example, we look at what square pyramid looks like. Remember, a square pyramid will have a base that is a square, okay, and it will have 4 triangular faces, okay. So a square pyramid will look something like this, okay. Not going to be as good as what you have there. Oops. Make that better. So this is supposedly the base of our square pyramid. Put the vertex there, and we simply, not that one, attach the edges to each of the vertices. That is how a square pyramid looks like, more or less. Okay? Now, if you have that square pyramid and you have what we call a vertical slice is this one right here, where you have your solid and a plane intersects through your solid this way, vertically. Okay? So if you notice in that cross section, okay, this is where they intersect and it forms a triangle. So in a vertical slice in a square pyramid, okay, the cross section is what we call a triangle. Okay? In an angled slice, such as this one right here, okay, where you have your square pyramid and you have the plane intersecting the square pyramid at an angled slice, you notice that it will form that shape, okay? And that shape is what we call, okay, a trapezoid. So remember what a trapezoid is. A trapezoid looks something like this. That is a trapezoid, very close to what you have there, okay? Finally, in a horizontal slice, the last one right here, where the plane intersects the square pyramid horizontally, it will create what we call very close to a square. Okay, so that means when it is when the plane intersects with our square pyramid horizontally, the cross section is a square. Okay, again, rewind any part of this video if you are still getting confused. Okay, do the guided problem. Let's see if you understand example number 3. And we are done with this lesson. Thanks for watching.